Welcome to Ocean Currents Part 2, Upwelling and Downwelling. In the first lecture, we talked about surface currents. And in the last lecture, we're going to talk about what's called thermohaline circulation. Upwelling and downwelling is kind of the bridge between those two. And it sounds just what it sounds like. Upwelling and downwelling. Upwelling and downwelling is basically just fancy words for vertical movement of water. Upwelling is bringing water up. So what's happening is the deep water that's down at the bottom of the ocean or towards the bottom of the ocean is coming up to the surface. And then downwelling is taking surface water and pushing it down into the deeper regions of the ocean. So upwelling is bringing up nutrient-rich water to the surface. In places where upwelling is happening, you'll see a lot of marine life, you'll see a lot of algae and phytoplankton, and a lot of growth in the food chain there, because what's happening is the nutrient-rich water is basically bringing up fertilizer. And what do we do with fertilizer? What's fertilizer for? It's for helping the plant life grow. So if the plant life can grow, then the animal life can then eat the plant life. So upwelling creates very strong, very abundant food webs in sites where upwelling is happening. Downwelling happens in other areas where the water actually from the surface water actually moves down and goes into deeper parts of the ocean. What it's doing is it's actually taking warmer water, and a lot of times gas-rich water. There's a lot of oxygen or carbon dioxide in there, both from the mixing with the atmosphere and then also from the ocean life that lived there and survived there as the water moves around the globe, as you saw in the last lecture with surface currents. Okay, and it actually sends it back down to the bottom of the ocean. Here you can see a picture of upwelling and downwelling. So a lot of times it's caused by wind, or let me rephrase that, it's propelled by wind. So wind moving in different directions, okay, will pull water, either pull it away from the sides of the ocean basin, which is basically where the continents are, the shores. Okay, it'll pull it away from the shore and actually cause it to kind of come up and go around. All right, so let's see if I use this will probably help. So you can see what's happening is as the water's blowing, as the wind is blowing, the water is being brought up from the bottom of the ocean, okay, and then pushed out away from land. All right, so it's kind of creating a circular current here. A lot of times they're referred to as convection currents when they do this. Convection currents. Oh my goodness, this is not going well. Convection. All right, and that is supposed to be an E-N, and there's a C in there. Convection currents, which are basically like little circles. So up, around, down, all right, and back over. So convection currents work in these little circular cells. Downwelling is the opposite. So we see the pink line of wind, okay? And what that's doing is that's actually pulling the water in towards the shore, and then coupled with the shoreline and the Coriolis current, which is this effect of the spinning of the earth, all right, is pushing that water back down into the bottoms of the ocean. Now, obviously, we can find upwelling and downwelling in different areas. And like I said, this is going to lead into our final part of currents, which is called thermohaline circulation, which is how this upwelling and this downwelling all fit together in the great scheme of ocean water movement. One of the big things that come along with upwelling or downwelling is, like I said, the food chains, the productivity, but one of the things, or the most notable things that can happen, is they can actually change. Upwelling and downwelling can actually flip-flop and change, And that's where we get things called oscillations. So the most famous of these oscillations is called El Nino, or Southern Oscillation, ENSO for short. Okay. And so what this is that this is a combination of issues going on, or not issues, but it's a normally occurring process. But this is a relationship between the oceanic interactions and the atmospheric interactions, and what happens as they change conditions. So El Nino is a warm surface current, okay, that ends up in the eastern Pacific, and it occurs usually around December. That's why it was called El Nino, because it happens right around Christmas time. Okay, Southern Oscillation is a change in the atmospheric pressure over the Pacific Ocean accompanying El Nino. And what ENSO is talking about is, like I said, it's that interaction between the oceanic and the atmospheric disturbances that changes how the water and the air interact, how that changes and how that affects the different things that are going on in this area of the world, which then also affect a lot of different weather patterns. If you have noticed in the past, they will talk about whether it's an El Nino year or a La Nina year, La Nina, which is the opposite of it, okay, and how that can affect our weather, and that can affect whether we have more snowstorms or we have more rain, warmer temperatures, cooler temperatures, and so on and so forth. So El Nino usually it's on a 2 to 7 year cycle. It can happen in a shorter amount of time, or it can take longer. Global climate change is definitely impacting El Ninos. So what happens is the sea surface temperature changes, the atmospheric wind change, and it also changes how upwelling happens. And one of the things that when we first started taking notice of El Nino, it was really creating problems for fishing, because it was really damaging food webs, because it was changing the upwelling and downwelling patterns in this area of the Pacific Ocean. So normal conditions, you can see we have the equator, not Ecuador, Ecuador is a country, the equator here, all right, and then we have North America, so you got North America over here, we've got South America over here, okay, and so what happens is usually upwelling brings that nutrient-rich water up here, okay, and that causes the food webs to flourish. Normally, off the coast of South America here in the Pacific Ocean, we end up getting really abundant food webs, really strong fisheries, really strong fisheries is just a general term for anything that comes out of the sea that we eat. So we usually have a lot of that really strong food web there because of this upwelling, bringing up those nutrient-rich waters. What happens is, okay, and then what it does is it pushes this cold water across the equator. Okay, as it moves across the equator, it warms up. Right? It gets to the other side, it sinks down, and we start this whole cycle all over again. Okay, and this is that convection current like I was talking about earlier in the Pacific Ocean. So we have upwelling on one side of the Pacific Ocean, we got upwelling up here, and then we'd have downwelling over here, okay, creating this cycle. So the water is going from cold South America, all right, to warm over in the Indonesian, Asia area. Okay. What happens with El Nino is that stops. Okay, El Nino conditions. Right, what happens is it's now changed. The weather patterns or the atmospheric patterns have now changed. So we have more warmer weather over here. All right, we're driving the warmer weather, or the warmer water, excuse me, across the equator to, again, South America. So instead of this being cold water that's coming up that's full of nutrients for the food web, it's actually pushing that water, that warmer water that's kind of been spent basically as it moves across the equator. It's being, the nutrients that was in it is being spent and pushing it the other direction. And so what happens is these fisheries during an El Nino season have less nutrients available for their phytoplankton, for their algae, which then disrupts the rest of the food chain. And also this change in the weather pattern, where we see a lot of times we have warmer, wetter weather here, it also affects productivity of other things, and it actually has consequences across the globe. So La Nina, okay, is kind of a stronger version of normal. All right, so if you can see the upwelling and the upwelling here, it looks very similar to normal. It's just a little bit larger, stronger. It brings up more cold water, but so again, it's not quite normal, but it's closer to normal. So it doesn't necessarily have as many effects as the El Nino, or we don't necessarily see the effects the same way we would for an El Nino oscillation. So here you can see down the line. Woohoo. Okay. All right. So here's a normal year. You can see here we have cold water, and we have that patch of cold water, and it stays cold as it moves across the equator. Whereas here, during El Nino, it's all warm water. Because that warm water is actually, it was warmed up over on the other side of the Pacific Ocean, right, and came across to South America, as opposed to here where the cold water, it's starting in South America and moving through the equator to the other side. So here's another depth profile. You can kind of see here where we see the upwelling, the colder water is coming up. The warmer water is sinking, so the colder water is coming up over here. The warmer water is sinking down over here. But then here in El Nino, you can see that brain fart. You can see that the warmer water is deeper off the coast of South America as opposed to what it was on the other side. Okay, and this thermocline is a word we're going to talk a little bit more when we talk about the ocean in the next lecture with thermohaline circulation. All right. This is where temperature is actually decreasing rapidly. And what's happening is the deeper down in the ocean we reach a point where the temperature drops dramatically, and then it kind of levels off because it's not really getting any new input. So from 1950 to 2005, you can see the El Nino events here. Okay, so as you can see, they're happening in very defined intervals. Okay, you can see up and downs. All right, but one of the things is that what we're noticing is that they're becoming more common. Okay, and you can see they're also becoming more extreme in some cases. So that's one of the things that we're looking at as one of the consequences of global climate change, is it's increasing or exaggerating this pattern. It changes weather patterns, it affects marine life, it affects food webs, it affects economic resources. Not only does it affect economic resources as far as those fisheries off the coast of South America, but it also affects weather patterns around the globe that affect crops, that affect agriculture, it affects food production. El Nino has a lot of far-reaching events. It also has a habit of causing more extreme weather conditions, mudslides and droughts in neighboring regions. Like one region could have mudslides, one region could have droughts. So it has a lot of effects. Okay, so you can see here some of those effects. The marine life is impacted. We get floods, we get droughts. That's one of the things is that El Nino and global climate change in general is it's not talking about always flooding. Okay, so in some areas of the world we might experience floods. Here, okay, in the Gulf of the US, we might be experiencing floods. But in other areas of the world, at the same time, they can be experiencing droughts. Okay? So it's global climate change and El Nino and all of these issues are not just about, like I said, it's not just about one side of the coin. It's about extreme changes to both characteristics or to both situations. So we end up seeing more droughts, but at the same time, we also see more floods in some areas. Okay, and then also we see storms, we see economic impacts from bird life, from marine life, from affecting food chains, food webs, agriculture. So there you go. All right. So that's the end of this lecture. Make sure you answer the discussion board questions, and I will see you later. Bye.